I don't think there's a topic I come across more than perspective that causes more problems to more people. And I'm not really sure why it's such a problem. I think sometimes perspective videos seem to overcomplicate what's happening, at least as far as understanding perspective for artists. Perspective is a theory that explains two certain truths, and they're so obvious it's almost embarrassing to tell you, that objects appear smaller as they go further away from us, and how an object looks depends on where we're looking at it from. Straight on, low down, side on, high up. Now, as I said, it's so basic, it's almost embarrassing to say. And yet, at heart, this is what the theory of perspective is explaining, these two truths. That objects appear smaller as they move further away from us, and how they look depends on where we're looking at them from. Well, if it's so obvious, why is there such a problem? Well, let's start with a cube, and we're looking at this cube straight on. Sorry, it's not quite as cubey as I would have liked it to have been. That's a bit better. So we're looking at this cube, and now I draw some cubes that are the same size further away, because it gets smaller faster. So we understand this really well. But perspective says things also change how they look if we change where we look at them from. So instead of looking straight on at this cube, let's walk around to the side and look at it side on to this edge here. And in that case, we get something that looks more like this. And I could draw some of these cubes to make them look as though they're further away by drawing them smaller. And again, that's really easy to understand. Again, where's the problem? But there is a fundamental difference in the appearance of our first cube and our second cube, because this side of the cube that we're looking at is square, as in fact all the sides of the cube are. But these two sides are not square. They've changed their shape. See, in this square, all parts of this square are fundamentally the same distance from us. We're looking straight on at this. But with this second cube, this corner is a lot closer to us than any other part of the cube. AA is closer to us than BB. And because BB is further away from us than AA, we apply our principles that things getting further away become smaller. It has to become smaller, or in this case, shorter. And so we see here the perspective principle at work, that as something moves further away from us, even though in life BB is the same as AA, BB appears smaller or shorter. But a two-dimensional shape has height and width. And it's not just the height that gets smaller, but the width gets smaller as well. Now, when we talk about width getting smaller, we talk about it narrowing. So as an object moves further away, the same object is moving further away. And the further away it goes, even if what we're looking at is the same side of the object, it appears smaller vertically and horizontally. Let me show you exactly how this looks by finding the halfway point in this box. Now we know that we can find the halfway point in a four-sided box by the diagonals, and so this is the halfway point. And if we look at this, we can see that the halfway point is much more over towards the further side than the closer side. But of course, if we were to do the halfway point in our square, then these would be equal. But what this does is it demonstrates to us really clearly that as this one wall of a building, say, moves further away, it becomes narrower and narrower vertically, and it becomes shorter and shorter horizontally. Now, The vertical change is obvious because it causes these lines to slope down. Because this line is shorter than these lines, then these lines have to slope down towards the new apparent height. It's not so obvious what's happening as we go widthwise. So let's look at another box. So let's take a rectangular box, like a shoebox, because we want a bit more space for what I'm about to do. Let's find the halfway point. And it's going to be here. Now it's further along than in our other example because this is sloping away at a steeper angle. So it's getting further away more quickly and it's a longer wall. But the other thing we can do is we can find the center line of each of these two spaces. And we can have one here. And what we can see is that as we move further away from us on the wall, that vertically things narrow as this wall appears smaller, or in this case, narrower, as it moves further away. And so although if we were to stand straight onto this wall and look straight at it, these four rectangles would all be the same size, they appear to be smaller as they move further away. And of course, we can repeat this any number of times we want. And we can see that for each of these now 8 boxes, they get narrower and narrower as they move further away. Let's just imagine that this wall is the wall of a building and we have windows the same size going down the wall. So let me add these windows in. And what we can see is that it's not just the wall that narrows as it moves further away, but everything on the wall appears to narrow as it moves further away. So even though all of these windows are identical sizes, the windows appear to get smaller. They appear to narrow as they move further away. And it's not just the windows that appear to narrow, but because these windows are all equally spaced, the gap between the windows also appears to narrow. And we can see that in this photo with the windows in this upper story of this house. We know that if we were to stand in front of this central door and look straight at this wall, that these windows would be equally spaced and would be all the same size. And yet, if we were drawing this building as it looks here, we would need to put each window slightly closer than the one before if we were drawing from the largest one to the smallest one. And we would have to not just draw the window narrower, but we would actually have to place it closer to the one before because the gap is narrowing as this wall and as the windows therefore move further away. But this is just that same principle at work, that things appear smaller as they move further away. They appear smaller vertically, so they're shorter, as in here and here, and they appear smaller in their width, which we call narrower, which we see in the windows and in the spaces between the windows. And if you can understand that, then you have understood the basis of perspective. Everything else is just more of a way of describing this. But what about all those other things we here talked about? Vanishing points, eye level, horizons, foreshortening. When we're talking about vanishing points and eye level, or horizon, as I think it is less helpfully also described as, we're usually concerned with these vertical lines and how much shorter they become, how quickly, and the lines that then join them up, because the angles that we have here, I call these the perspective lines, and I call these the perspective angles as well. But when we're talking about eye level and about vanishing points, we're concerned with how the height of an object is becoming shorter as it moves further away. But when we talk about how the width of an object narrows as it moves further away, we talk about foreshortening. We describe this effect with the term foreshortening. So they're each two sides of a coin, but together they describe all of the things that are affecting how an object changes in appearance as parts of the object move further away. And so we can see this at work in this building here. Where as it moves further away from us, it gets smaller vertically. The further side appears shorter than the closer side, and it gets smaller from us on its width. It narrows faster and faster as it moves further away. And so the halfway point in this building, this door, in fact, appears to be closer to the further end, because the half of the building to the left of the door appears to narrow faster as it moves further and further away than what we see on the closer half of the wall. And for many artists, this is really all we need to know if we either draw from references or draw from life, because this alerts us to what we're looking at, and it helps us to see what we're looking at more accurately, more easily. And if I can see my reference more accurately, more easily, then I have a better chance of drawing it accurately, if that indeed is what I want to do. And this is how I draw. I use perspective theory to understand better, more easily, what I see. It lets me identify the angles more easily. I know to pay attention to how quickly do the windows narrow and how quickly do they move closer together. I know that this door will not be in the center of this width, even before I carefully observe my reference to work out exactly where to put it. It gives me such a head start when I look at my photo, because I can anticipate many of the things I'm going to see. Now, if I want to draw a building, if I want to create a building or a street from my imagination, then I need to have a stronger understanding than this. But if my drawing practice is to copy what I see, then this basic framework for understanding perspective, I believe, fits the bill for helping us to observe what we're drawing more accurately, more easily. And in fact, I used these principles when I drew this scene for an earlier video. And you can see that the windows get closer together and become narrower and narrower, not just in this building, but in this building as well. Although this building has a curved front to it, which creates some other dynamics. G'day, I'm Stephen Travers. Look, I hope if you've struggled with perspective, that this absolute stripped down, bare bones explanation of what we're talking about when we talk about perspective has been helpful. I hope for anyone who has struggled to understand really the perspective videos they watch, that this is a light bulb moment that becomes a foundation for perhaps looking back over some of those videos again and understanding more deeply what's being said. But look, whatever you're drawing and however you're drawing it, make sure you have fun. I'll see you next time. Bye.